Oil Tankers Part 4 Fleet Characteristics. In 2005, oil tankers made up 36.9% of the world's fleet in terms of deadweight tonnage. The world's total oil tankers deadweight tonnage has increased from 326.1 million DWT in 1970 to 960.0 million DWT in 2005. The combined deadweight tonnage of oil tankers and bulk carriers represents 72.9% of the world's fleet. Tankers generally have cofferdams forward and aft of the cargo tanks, and sometimes between individual tanks. A pump rim houses all the pumps connected to a tanker's cargo lines. Some larger tankers have two pump rims. A pump rim generally spans the total breadth of the ship. Hull designs. A major component of tanker architecture is the design of the hull or outer structure. A tanker with a single outer shell between the product and the ocean is said to be single-hulled. Most newer tankers are double-hulled, with an extra space between the hull and the storage tanks. Hybrid designs such as double-bottom and double-sided combine aspects of single and double-hull designs. All single-hull tankers around the world will be phased out by 2026, in accordance with the International Convention for the Prevention of Pollution from Ships, 1973, MARPOL. The United Nations has decided to phase out single-hull oil tankers by 2010. In 1998, the Marine Board of the National Academy of Science conducted a survey of industry experts regarding the pros and cons of double-hull design. Some of the advantages of the double-hull design that were mentioned include ease of ballasting in emergency situations, reduced practice of saltwater ballasting in cargo tanks decreases corrosion, increased environmental protection, cargo discharge is quicker, more complete and easier, tank washing is more efficient, and better protection in low-impact collisions and grounding. The same report lists the following as some drawbacks to the double-hull design, including higher build costs, greater operating expenses, for instance higher canal and port tariffs, difficulties in ballast tank ventilation, the fact that ballast tanks need continuous monitoring and maintenance, increased transfers-free surface, the greater number of surfaces to maintain, the risk of explosions in double-hull spaces if a vapor detection system not fitted, and that cleaning ballast tanks is more difficult for double-hull ships. In all, double-hull tankers are said to be safer than a single hull in a grounding incident, especially when the shore is not very rocky. The safety benefits are less clear on larger vessels and in cases of high-speed impact. Although double-hull design is superior in low-energy casualties and prevents spillage in small casualties, in high-energy casualties where both hulls are breached, oil can spill through the double hull and into the sea, and spills from a double-hull tanker can be significantly higher than designs like the mid-deck tanker, the Columbia tanker, and even a pre-MARPOL tanker, as the last one has a lower oil column and reaches hydrostatic balance sooner. Inert gas system. An oil tanker's inert gas system is one of the most important parts of its design. Fuel oil itself is very difficult to ignite, but its hydrocarbon vapors are explosive when mixed with air in certain concentrations. The purpose of the system is to create an atmosphere inside tanks in which the hydrocarbon oil vapors cannot burn. As inert gas is introduced into a mixture of hydrocarbon vapors and air, it increases the lower flammable limit or lowest concentration at which the vapors can be ignited. At the same time, it decreases the upper flammable limit or highest concentration at which the vapors can be ignited. When the total concentration of oxygen in the tank decreases to about 11%, the upper and lower flammable limits converge and the flammable range disappears. Inert gas systems deliver air with an oxygen concentration of less than 5% by volume. As a tank is pumped out, it is filled with inert gas and kept in a safe state until the next cargo is loaded. The exception is in cases when the tank must be emptied. Safely gas-free in a tank is accomplished by purging hydrocarbon vapors with inert gas until the hydrocarbon concentration inside the tank is under about 1%. Thus, as air replaces the inert gas, the concentration cannot rise to the lower flammable limit and is safe. Cargo operations aboard oil tankers are governed by an established body of best practices and a large body of international law. Cargo can be moved on the roof of an oil tanker in several ways. One method is for the ship to moor alongside a pier, connect with cargo hoses or marine loading arms. Another method involves mooring to offshore buoys, such as a single-point mooring, and making a cargo connection via underwater cargo hoses. A third method is by ship-to-ship transfer, also known as lightering. In this method, two ships come alongside in open sea and oil is transferred manifold to manifold via flexible hoses. Lightering is sometimes used where a loaded tanker is too large to enter a specific port. Pre-transfer preparation. Prior to any transfer of cargo, the chief officer must develop a transfer plan detailing specifics of the operation, such as how much cargo will be moved, which tanks will be cleaned, and how the ship's ballasting will change. The next step before a transfer is the pre-transfer conference. The pre-transfer conference covers issues such as what products will be moved, the order of movement, names and titles of key people, particulars of shipboard and shore equipment, critical states of the transfer, regulations in effect, emergency and spill containment procedures, watch and shift arrangements, and shutdown procedures. After the conference is complete, the person in charge on the ship and the person in charge of the shore installation go over a final inspection checklist. In the United States, the checklist is called a Declaration of Inspection or DOI. Outside the US, the document is called the Ship/Shore Safety Checklist. Items on the checklist include proper signals and signs are displayed, secure mooring of the vessel, choice of language for communication, securing of all connections, that emergency equipment is in place, and that no repair work is taking place. Loading cargo. Loading an oil tanker consists primarily of pumping cargo into the ship's tanks. As oil enters the tank, the vapors inside the tank must be somehow expelled. Depending on local regulations, the vapors can be expelled into the atmosphere or discharged back to the pumping station by way of a vapor recovery line. It is also common for the ship to move water ballast during the loading of cargo to maintain proper trim. Loading starts slowly at a low pressure to ensure that equipment is working correctly and that connections are secure. Then a steady pressure is achieved and held until the topping off phase when the tanks are nearly full. Topping off is a very dangerous time in handling oil, and the procedure is handled particularly carefully. Tank gauging equipment is used to tell the person in charge how much space is left in the tank, and all tankers have at least 2 independent methods for tank gauging. As the tanker becomes full, crew members open and close valves to direct the flow of product and maintain close communication with the pumping facility to decrease and finally stop the flow of liquid. Unloading cargo. The process of moving oil off of a tanker is similar to loading, but has some key differences. The first step in the operation is following the same pre-transfer procedures as used in loading. When the transfer begins, it is the ship's cargo pumps that are used to move the product ashore. As in loading, the transfer starts at low pressure to ensure that equipment is working correctly and that connections are secure. Then a steady pressure is achieved and held during the operation. While pumping, tank levels are carefully watched and key locations, such as the connection at the cargo manifold and the ship's pump room, are constantly monitored. Under the direction of the person in charge, crew members open and close valves to direct the flow of product and maintain close communication with the receiving facility to decrease and finally stop the flow of liquid.